February 1959, shaft sinking was completed at Parkside Colliery. The first new pit to be sunk in the Northwestern Division for more than 30 years, Parkside set up a record for shaft sinking in this country. Sinking the shafts of a new pit has always been a long and costly job. Rapid sinking means not only getting into production sooner, but at the same time saving up to £2,000 a day in interest and other charges. After 3 years of planning, the sinkers took over in June of 1957. Number 1 shaft, 24 feet in diameter and concrete lined, had to go down 889 yards. Number 2, the upcast shaft, had 886 yards to go. The 3 insets of each shaft were to be constructed after sinking was finished. We'd known for a long time there was plenty of good coal beneath Parkside, but now we wanted to get to it fast. Could we double the normal rate of sinking? Well, first we needed new techniques for sinking at high speed, that was certain. But just as important, we needed the men with the experience to use these techniques. In the end, we found what we were looking for. During the pre-war and war years, when there had been few new pits sunk in Britain, they'd been developing rapid sinking techniques in South Africa. So we called in their specialists to help us with our particular sinking problems. But it wasn't high speed all the way. For the first 500 or 600 feet, it was slow work going down through the heavily water-bearing sandstone. Instead of the hard, dry rock of the Gold Belt, we had a water intake of up to 1,400 gallons per hour and friable walls. At 150 feet down, the South Africans took over and put in a specially constructed 3-deck scaffold. But it wasn't until we pulled out of the water-bearing strata that we started to speed up. From then on, we advanced 15 feet in a 2-day cycle, working 3 shifts a day and 7 days a week. In our best month, we did 103 yards, 3 times the usual rate in this country. We knew that high speeds in shaft sinking depended on powerful loading equipment and adequate winding capacity, on a smooth flow of materials, and on creating a rhythm of work as nearly continuous as possible. We designed a system of operations to cut down all shaft movements to a minimum. The 3 working platforms allowed us to do many jobs simultaneously, and the heavy scaffold was only moved into 3 positions, 1 for mucking, 1 for firing, and 1 for walling. The wall shuttering was left in the shaft all the time, and winch lowered in complete rings from one level to another. We used a larger mechanical grab than before and slung it beneath the scaffold. But now let's take a closer look at the shaft equipment in model. Just beneath the bottom platform of the scaffold can be seen the 15-foot section of steel shuttering which holds the permanent lining of the last cycle. It has 5 horizontal sections, a curb piece, 3 center sections which can be lowered as one, and a top or matching piece. These remain permanently in the shaft and are used from one cycle to the next. The working platforms are spaced 15 feet apart, and there are 2 square holes in each platform to allow for double drum winding. The 4 main hoist ropes are also used as steadying guides for the 2 kibble riders. As an empty kibble comes down, its rider is halted by the stops just above the deck, and the kibble continues more slowly through the platforms of the scaffold and down to shaft bottom. The scaffold is further supported by 8 safety slings. These are hung from pins inserted in the concrete wall 150 feet up. The top platform is used for extending the various service pipes. Ventilation, compressed air, water, concrete feed pipe and cables. It also shelters the 2 lower platforms, which are used mainly during concreting. Concrete is gravity fed through a main hose into a distribution box in the middle of the center platform. From this, 4 outlet hoses can direct the flow to all parts of the wall. 6 hand-operated winches, 3 on the far side and another 3 on the near side, are used to lower the steel shuttering. The 4 flexible hoses pass into 4 extension hoses in the floor of the bottom deck. This deck gives access to the wall shuttering when the scaffold is in its concreting position. Beneath the bottom platform is the loading equipment. The whole assembly turns about this center pivot, whilst the outer end of the jib travels on a monorail around the edge of the platform. Mounted beneath the center pivot, the operator has a clear view of the whole of the shaft area. The jib houses the compressed air motor, which moves radially to and fro, so allowing the grab to reach any part of the shaft. When dirt is being wound, 4 kibbles are in use, 2 at shaft bottom and 2 winding. At the bottom, 1 kibble is full, waiting to be wound, whilst the other is being loaded. Here, the full kibble has been exchanged for an empty. It is hoisted slowly up through the stage, steadied by hand from the platforms until it reaches the top deck, where the rider is picked up and the kibble can be wound at speed. Balancing the upward wind, an empty descends on the other side. Double drum winding is the minimum essential if the shaft and loading equipment are to be used to full capacity. At the beginning of a new cycle, after the wall has been lined, there is spoil left over from the previous pull. So the first phase is mucking out. We have